Let's explore the sudo command. Sudo allows authorized users to execute commands with the security privileges of another user, typically the superuser or root. It stands for substitute user do. The basic syntax of the sudo command is as follows: sudo, then options, then the command. The sudo command temporarily elevates your privileges, allowing you to run commands that require root access. For example, sudo apt update. This command updates the list of available packages. Another example is sudo system control restart Apache 2. This command restarts the Apache 2 web server. Sudo I gives you an interactive shell as root. Sudo u Postgres PSQL runs the PSQL command as the Postgres user. Remember, you'll be prompted for your password when using sudo, not the root password. Let's examine some common sudo options. The I option simulates an initial login. It runs the shell specified by the target user's password database entry as a login shell. For example, sudo I. The S option runs the shell specified by the shell environment variable, if it is set, or the shell specified by the target user's password database entry. For example, sudo. The U option runs the specified command as a user other than root. The user can be either a username or a user ID. For example, sudo u Postgres PSQL. The K option invalidates the user's cached credentials. The next time sudo is run, a password will be required. For example, sudo k. Here are more sudo options. The L option lists the allowed and forbidden commands for the current user on the current host. For example, sudo L. The V option updates the user's cached credentials, extending the sudo timeout for another 15 minutes by default. For example, sudo v. The B option runs the given command in the background, returning control to the terminal immediately. For example, sudo b apt upgrade. The E option preserves the user's environment variables when running the command with elevated privileges. For example, sudo i/install.sh. Let's look at some practical examples of using sudo. Package management operations typically require root privileges to install, update, or remove software. Sudo apt update updates the package list. Sudo apt upgrade y upgrades all installed packages. Sudo apt install Nginx installs the Nginx web server. Managing system services requires elevated privileges to start, stop, or check status. Sudo system control start Nginx starts the Nginx service. Sudo system control enable MySQL enables the MySQL service to start on boot. Sudo system control status Apache 2 checks the status of the Apache 2 service. Modifying system files or accessing protected directories requires sudo privileges. Sudo nano/etc/hosts edits the hosts file with nano. Sudo cpconfig.conf/etc/app copies a configuration file to a system directory. Sudo chmod 755/var/www/html changes the permissions of a directory. Creating, modifying, or deleting user accounts requires administrative access. Sudo add user new user creates a new user account. Sudo usermodg sudo username adds a user to the sudo group. Sudo password username resets the password for a user. Let's explore some advanced uses of sudo. The U option allows you to run commands as users other than root. Sudo u Postgres PSQL runs PSQL as the Postgres user. Sudo u www.data PHP script.php runs a PHP script as the www.data user. Sudo u nobody ls/tmp lists the contents of the /tmp directory as the nobody user. This is useful for testing permissions or running applications as their service user. Note that you must have sudo privileges to run commands as other users. By default, sudo resets most environment variables for security. Use Z to preserve them. Sudo i/install.sh runs the install script with the current environment variables. Export database password equals secret. Sudo e python setup.py runs the Python setup script with the database password variable available. This is particularly useful when scripts need access to your user's environment variables. Be cautious when preserving environment variables, as it can potentially introduce security risks. The /etc/sudoers file controls who can use sudo and what commands they can run. It defines which users can use sudo, which commands they can run, whether a password is required, and how long the sudo session lasts. Never edit the sudoers file directly. Always use vsudo, which checks for syntax errors. Here are some example sudoers entries. Allow user John to run all commands without a password. John all satface all. No password. All. Allow members of group developers to restart web services. %developers all satface all. /bin/system to restart Nginx. /bin/system to restart Apache 2. When using sudo, there are important security considerations to keep in mind. First, the principle of least privilege. Grant users only the minimum level of access they need to perform their tasks. Avoid giving full sudo access when limited permissions would suffice. Use specific command permissions in sudoers rather than all access. Next, session timeout. By default, sudo caches your password for 15 minutes. Consider adjusting this timeout in environments requiring higher security. Set defaults timestamp _timeout equals 5 in sudoers to reduce the timeout to 5 minutes. Next, logging and auditing. Sudo logs all commands to syslog by default. Regularly review these logs to detect unauthorized or suspicious activities. Check logs with grep sudo /var/log/auth.log. Finally, avoid running graphical apps. Running graphical applications with sudo can change ownership of configuration files in your home directory, potentially causing permission issues. Use pexec instead of sudo for graphical applications when possible. Here are some common mistakes to avoid when using sudo. Using sudo with text editors. Running text editors with sudo can create files owned by root in your home directory, causing permission issues later. Incorrect. Sudo getItFile.txt. Correct? Sudo efile.txt or sudo editfile.txt. Redirecting output. Redirection happens before sudo executes, so the shell doesn't have elevated privileges for the redirection. Incorrect. Sudo echo text greater than /etc/file. Correct? Echo text pipe sudo t/etc/file. Using sudo with aliases. Shell aliases don't work with sudo by default, as sudo doesn't expand aliases from the user's shell. Incorrect. Sudo ll, if ll is an alias. Correct. Sudo $, which ls, la or alias sudo equals sudo space in .bash. Running everything as root. Using sudo for every command is unnecessary and potentially dangerous. Only use sudo when elevated privileges are required. Incorrect. Sudo ls, unnecessary, and sudo cd/var/www won't work. Correct. Only use sudo when needed. Let's review some best practices for using sudo. Use specific permissions. Configure sudoers to grant access only to specific commands that users need, rather than providing full sudo access. This limits potential damage from mistakes or compromised accounts. Review sudo logs. Regularly check sudo logs to monitor usage patterns and detect potential security issues. Look for unauthorized access attempts or unusual command execution. Use sudo edit for files. When editing system files, use sudo edit or sudo e instead of running the editor with sudo. This preserves file ownership and permissions while still allowing edits to protected files. Double-check commands. Always verify sudo commands before executing them, especially destructive ones. A simple typo with elevated privileges can cause significant system damage that may be difficult to recover from. The sudo command is a powerful tool that balances security with convenience. Use it wisely, understand its capabilities, and follow best practices to maintain system integrity and security. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.